Okay, this video is about parabolas, section 9.2, and this is part 1. Okay, we'll talk about the definition of a parabola as a set of points that satisfy a certain criterion, like we did with the circle, ellipse, and hyperbola. Okay, so in the case of a parabola, there will be one fixed point called the focus, just one focus, and there will be a fixed line, which is called the directrix. And a parabola will consist of all the points that are equidistant from the focus and the directrix. So, for example, this point P here is on the parabola. Its distance to the focus equals its distance to the directrix. All right, so you could take any point on the parabola and you would measure that distance to the focus and you would measure its distance to the directrix. And it should always be, they should be equal distances. All right, now there are 4 different ways that our parabolas will be oriented. The parabola will either open up or upward, or down, open to the right, or to the left. Those will be the 4. And for the time being, we'll stick with the center or the vertex being the origin. Now, the one thing you'll notice that all of these have is that the parabola itself opens going away from the directrix. It goes in the direction away from that line, and that the focus is inside of the parabola itself. So that's always going to be true no matter which way that it's oriented. Now, if we look at the standard form equations, okay, for the case where the directrix is horizontal, and we're talking about the parabola either opens up or down, it'll be in this general form. X squared equals 4 times p times y. So for example, you might have x squared equals 24y, or x squared equals negative 16y. Those fit in this form. Now, we've seen these before, it's just that the ones that we dealt with before were all functions, and usually we would solve the equation for y. If you say took this equation and solved it for y, divided by 24, you would have y being equal to 1/24 times x squared. That's the form that we're used to before, and then we said that it had an a value of 1/24. Versus this one, if you solve it for y, you've got y equals negative 1/16 x squared. This had an a value of negative 16. And so we learned if the a value was positive, the parabola opened up, and if it was negative, the parabola opened down. It's something similar here. We're not going to work with a, we're going to be working with p, which has a slightly different meaning, but a positive p value will open it up or down if it's got a horizontal directrix. Now, if you have a vertical directrix, this would be where the parabola is either opening to the right or to the left. Then your form is going to be y squared is equal to 4px. All right, and here's an example of where it opens to the right. You'll notice it's positive here, and then opening to the left, you have a negative. Now, the thing you should notice about both of these is only one of the variables is squared. If the x is squared, then it opens up or down. If the y is squared, then it opens left or right. Now, we'll be taking equations in general and solving for the specific value of p, and that number is very useful. When it comes to a parabola, you can measure it using the value of p. And it doesn't really matter whether the parabola opens up or to the right. It's going to be the same basic idea. So you'll have the vertex of your parabola. If it's opening upward, the vertex will be the lowest point on it. If it's opening to the right, the vertex will be the point farthest to the left. Right? But if you measure from the vertex to the focus, that amount, that will be p units. All right? If you measure from the vertex to the directrix, that is also p. Now I'm assuming here I'm just looking at p as being a positive number. I'm talking about the absolute value of p when I'm talking about a distance there. And then also, if you form a line segment going to the focus and parallel to the directrix. If you form this line segment here, right? It's actually called the latus rectum. Not my favorite name for a line segment, but it has a nice length that can be measured using p. From the focus to here, that is 2p. If you go from the focus to the other side of the parabola, that is also a measurement of 2p. So you can start with the vertex and measure p units to get to the focus. You can go the opposite way and get the directrix. If you're at the focus, you can go 2p to the right and 2p to the left and get some points on the parabola. So when it comes to actually graphing the parabola, these are the only points on the parabola. The focus and the directrix, those are kind of like extra. Basically what you're going to want to do is first you're going to want to plot the vertex, which at first it'll just be 0, 0 as we get started. And then you'll use the value of p to plot the focus and the directrix. And then you'll use the focal diameter 2p to find 2 additional points besides the vertex that are on your parabola.